This is Lab 4 by Rhiannon Crisanti. The lab is meant to help us understand oscillating motion by comparing predicted and experimental data and understanding what the differences are and why these differences have occurred. So this is some of the given information where all of this was given by the video that I derived my data from. And here are some of our fundamental formulas, like Newton's second law, and of course anything having to do with kinetic and potential energy that we are going to be including in here today. So this is our actual video. So there's an attached point here, and then our system, the spring, is oscillating with all of the surroundings around it, which is the room, the earth, all of that. And we can use the information from where we started, which was a point around here, and use that to actually do our coding. Okay. So initial conditions are going to be the same as whatever the initial conditions of my data were, where my initial conditions are included up here. So this was our initial position vector and our initial velocity vector, because we did not start with any velocity. And then down here we're inputting all of our known data using some of our given information and our FS formula. And then up here we're using our potential and kinetic energy formulas, adding them all up for total energy. And then down here we are using the same formulas, just updating them by adding them to our, changing it and finding the delta by taking our initial and subtracting that from our final kinetic energy or potential energy. And then of course Newton's second law, just updating the position and velocity functions here. And then some force vectors here to find Fnet. So what is our visual representation? That's going to look like this. So what does it mean? Is the energy principle satisfied? Which is a yes, because as you can see, the orange line remains a constant line right here at 0, which is something that we want. We want the same exact energy, and when you total all of the energy, the changes in energy, and we want it all to end up with 0, so that energy principle is satisfied because the change in energy is 0. And then our visual representation of what the actual swinging motions look like. As you can tell already, the data is slightly different. What could be causing errors are things like air drag that might be happening in the background that we can't really take into account at the moment. And it could also just be that my K values or initial values might have been slightly off. So our final question, what does it mean? So taking the information obtained through the tracker, we were supposed to find oscillation periods. This is the oscillation period for the X by finding where each of these points are approximately, same with this. And while this remains extremely stable with each point only being slightly to the left or right, as you can tell, this is a lot more wildly different. But the two oscillation time periods were overall actually extremely similar.